Hi everyone. Today I want to talk about transforming sine and cosine graphs. That's not exactly what it says. I ad-libbed. Here's our beautiful sine x graph, the parent function. Nothing's changed. Everything's pretty legitimate, pretty simple. Here is our formula to help us remember our ABCs and Ds. ABC. Okay. A stands for the amplitude, which is the height, and again, that comes from the x-axis to its highest point. The period represents one full cycle of the trig function before it repeats, and that is represented by our b value, and we can find that by doing 2 pi divided by b. B is usually the coefficient of the function or the equation. We'll get there. C stands for the phase shift. Phase shift is just a fancy term for horizontal shift, left or right. And then D is our midline, which, again, not really called that so often, but it's just our vertical shift up or down. Cosine function, certainly no change there from the last time you saw me. Again, we have the same formula, but again, we changed it to cosine instead of sine. And again, we have our A, B, C, and D values. So, hey man, when I said give them some examples, I didn't say to, make it a little way too difficult. Huh? Oh, you wrote me a note? Really? Go big or go home. That's fair. Let's do this together. He didn't really write on there. I made that up. All right, so again, we have our two formulas, just sine and cosine. There's no challenge there, no difference there. And our A, B, C, and D. Titan is a little bit correct in terms of going big or going home. Clearly, example 1 and even example 2, we can make the case is not too bad. Example 3, and I can guarantee you 4 and 5 on the other page, are pretty bad too. You can thank the dog for that one. So let's go ahead and do what we know for number 1. Number 1 is y equals 5 cosine x. Now, really, there's only one transformation that occurred to this because we know the parent function was cosine x. Well, 5 is, if you want to call it the coefficient or the number in front of the actual equation, cosine x. 5 represents our a value. All right? So if 5 is our a value, that means the amplitude of this function is 5, meaning its height is 5. So if we were to graph it, which we'll do in another video, we want to go from the x-axis 5 units up, right? And then clearly we would go 5 units down as well, but we'll go from there. Now, let's go ahead and fill in the rest of this, because there are still other values in terms of the transformations. They're just the basis or the parent functions one. So B stands for the period, which is one full cycle. Well, there is no number in front of x. B usually is the coefficient of x. Now, in all of these problems, sidebar, x is what represents the angle measurement or the representation of the angle. Theta is what you're going to see as well. So it could be interchangeable. You might see x there or you might see theta. So just be prepared for that, okay? So our b value again is going to be the coefficient of x. Well, coefficient of x is 1 here. So we would divide 2 pi over 1, right? Because again, the coefficient of x is 1. So our b value is 2 pi. Now remember, b is our period. So that's going to be one full cycle before the function repeats. Now that makes sense because we know that cosine x does repeat after 2 pi. Right? So we know that since there was no number indicating that there was any kind of a horizontal stretch or shrink, we know it's going to be a 2 pi value. Right? C is our phase shift, left or right. We can find that out by doing c divided by b. And again, we would take the number to the right of x and divide it by our b term. Now, one other sidebar that we'll see very shortly is b is not always in a parentheses or in between parentheses by itself. So if we take a look at, I don't know, number 3 here, we are going to have to factor out some things to help us understand a little bit more of what phase shift is. But again, let's get there step by step. Again here, there is no value for c. There is no plus or minus next to this x. So c is going to be no change or 0 change in terms of horizontal left or right. Okay? D is the midline, which is the vertical shift. And again, there's no plus D on the end of this. You would actually see a plus or minus at the very end. So D, there was no change vertically. So there's our A, B, C, Ds, right? Amplitude is 5, that's height. B is our period, which is 2 pi. Again, what happens, or in the midst of one revolution. So that's one revolution, 0 to 2 pi, but we say that the actual period is 2 pi because it goes, that's the length, 2 pi. C and D, horizontal shift, that's left or right, up or down, 0 as well. Now, let's go to example 2. Example 2, we've got 3 sine times the quantity of x minus 5 pi over 6. So again, let's take it step by step. A is the amplitude. A is the number that's in front of the trig function. A is 3 here. Again, that's going to be the height up and down from the x-axis. Now, this part's going to be a little bit interesting. Our b value here, well, let's take a look. Is anything in front of x? Meaning, is there anything in between this parentheses and that x value? And the answer is no. Well, technically it's 1, but no, there's not. So the period is not going to change here. The period is still going to be 2 pi. Because there's no number in front of x, right? And if there was, then we would be able to do 2 pi divided by that number. But since there is no number there, or it's just 1, 2 pi divided by 1 is just 2 pi. Now, C, again, stands for our phase shift. Horizontal shifts are going to be inside parentheses. Now, the way to remember it is like this. Anything on the outside of the parentheses, any number on the outside of the parentheses that's added in is actually what we call a truth teller. And a truth teller is exactly what you see is exactly what you get. It's not trying to trick you. It's not the opposite. It's literally exactly what you see. But when there is a number with a sign on the inside of parentheses, we call those liars. They're trying to trick you, and it's actually the opposite of what it looks to be. So let's take a look at this for a second. Phase shift is horizontal left or right. Inside of the parentheses, this is C right here, negative 5 pi over 6. Negative sign is not left. Now remember, we're talking about horizontal. So the negative sign, you would think, well, negative's left. It goes this way on the x-axis. Well, no. It's in parentheses, and it's a liar. This is actually a phase shift right 5 pi over 6. Now, coincidentally, if this was at plus 5 pi over 6, it would be left 5 pi over 6. Okay? So we're going to get used to seeing that value in parentheses and really just trying to trick us on purpose. D stands for the midline or vertical shift. There is no plus or minus on the end, so there is no vertical shift up or down. Okay? Let's move on to number 3. Thanks, Titan. A is the amplitude, and it is the number in front of the trigonometric function. The amplitude is 2 here, so again, the height is going to be 2. Now, let's talk about B, which is going to be our period. Now we have a coefficient in front of x. That number, whatever that is B, right? So if we want to label things, A is 2, B is negative 3, C is that negative pi over 2, and D is 2. See how ABCD works out so nicely? I know. I didn't create it. I can't take credit for that. B is the period. Well, negative 3 is in front of x. And because B is negative 3, what does it say to do? It says to take 2 pi and divide it by B. Well, because those values don't go into each other nicely, we're just going to simply state the period as is. Now, hear me out. The period is 2 pi over 3. I know what you're saying to yourself. What happens to the negative? Well, we can't have negative periods because, as we know, if the period, if we go back to the parent function, if the period of sine and cosine is 0 to 2 pi, meaning 2 pi, that means it's 2 pi going to the right, another 2 pi going to the right, 2 pi going to the left. There is no negative value necessary because, again, when we talk about trig functions, they're not actually negative. They just go the other way, clockwise, on the unit circle. So it's kind of like when we talk about amplitude, it's got to be in absolute value terms, the distance from 0, or in this case, the distance from the intercepts. So when there is a negative value in front, or our B value is negative, we ignore the negative part when we talk about period, because the period is just 2 pi over 3. More practice coming on that. Let's talk about C for a second. So C is going to be our phase shift, left or right. Now, here's where this gets a little tricky. We cannot just say that it's right pi over 2. And the reason for that is because there's something else here inside this parentheses. We have to factor out or divide out that negative 3 from that pi over 2. Now, let's take a look at our new addition here for phase shift. This is just going to be a little easier of a way to remember it. We find phase shift by doing C divided by B. So we're going to do this negative pi over 2 divided by negative 3. I'm going to do that up here. So we take the C value and divide it by the B value. It's just a really easy way to remember how to do this. So our C value is negative pi over 2, divided by the b value of -3. But just like when we find like tangent values or cotangent values or something to that nature of unit circle measurement, we can't divide fractions, so we're going to multiply by the reciprocal, just like we did for the unit circle. So let's write this out long ways. This is -pi over 2 divided by -3. But again, we don't do that. We write -pi over 2 times 1 over -3, because that was -3 over 1. This is what we're looking for, right? Because now we can multiply those fractions together and get actually what the phase shift is. Negatives cancel out. Multiplying across gives me pi over 6. That is the phase shift of this function. The c value or phase shift is pi over 6. Now, what direction is that? Because this is a positive value. Well, if I were to write it with a plus sign, remember it's going to stay in parentheses. So this is actually pi over 6 to the left. And that is going to be our value for the phase shift. Left, pi over 6 units. Whew, I know. But we're not done. Hopefully you know what our vertical shift is going to be. That's the easy one. It's +2, meaning up 2. Thanks a lot, Titan. Let's try some more difficult ones. I swear, man, this is the last time I'm ever going to let you do... Hello. Example 4. Y equals cosine times the quantity of x over 4 plus pi over 4 minus 2. Amplitude is the number in front of the cosine value. Well, there is no number in front of cosine, so the amplitude is just 1. Right? That's all it is, right? Because there was nothing there. I can't say 0 because if it was 0, it would cancel everything out. It's 1. Now remember, on our parent functions, it's 1 anyway, because it goes to 1 on top and it goes to -1 for its minimum, right? So it's just 1. B represents the period. Now again, this is going to be a little funky because there's a fraction. Remember that b is the coefficient of x. Now, x over 4 really says 1x over 4, or 1/4 times x. So we can say 1 over 4 is the b value. But we have to, according to our rule here, divide that 1/4 with the 2 pi on top. So that's what we're going to do. We're going to do 2 pi over 1 over 4. And again, why is it 1 over 4? Because it's the coefficient of x. Now, this is just another way to represent x over 4. X over 4, and I'm going to do it over here just so you see it. X over 4 means 1 over 4 times x, right? So it's just an easier way to represent that because I could certainly put the 1 in front there, all right? This is a little bit more preferred because we can see the x more clearly and the coefficient clearer, but it's just the same exact value, okay? Because we can just say it's 1x over 4, which is 1 over 4 times x. Okay, now let's divide this out like we did before. This is 2 pi divided by 1 over 4. But we can't do that, so we're going to do 2 pi times 4 over 1, which is 8 pi. That is the period of this function. And again, how did we get that? Well, we know that the period is 2 pi over the b value. If we want to write our numbers here, or our letters over our top of our numbers, A, B, C, and D. Now, again, the b value is 1 over 4. So I have to divide 2 pi by 1 over 4. We do it the long way, just so you can see it in fluency, and we have 8 pi. The period is 8 pi for this function. It's a pretty big period, which means what happened is it got horizontally stretched by a significant number because it goes 8 pi before it repeats. And that's a big, big, big stretch. So instead of it being like crunched up and being like really, really, really squiggly, it's going to be like very slowly squiggly throughout. And again, when we start to graph these things, you'll be able to see what's really happening here, okay? C is the phase shift. And we're going to do c divided by b. Now remember, we have a value here that was a 1 over 4. So we're actually going to divide pi over 4 by 1 over 4. So let's go ahead and do that. I'll erase this part, and we will divide those two fractions and get something just pretty disgustingly sickening. All right, pi over 4 divided by 1 over 4. Well, again, we don't do that, right? So what do? We do pi over 4 divided by 1 over 4, which is the same as pi over 4 times 4 over 1. Well, the 4's cancel by cross-canceling, and I get just pi. That means the phase shift for this function is just pi units. Now, what direction, right? Because phase shift is left or right. Well, that's a positive value, so that means that this went pi units to the left. So our phase shift was left pi units. And then D, after we get all through that craziness, we just have a good old -2, meaning down 2. Yeah, okay, last one. You can certainly try it if you want to, but I'm going to work it out because this is heavy duty. Okay, if you want to write your values on top, it's always a good idea to do that, right? A, B, C, and D, right? Okay, so let's go with what we know. The A and the D, super, super easy to remember, right? A is the number in front of the function, D is the one at the end. So please don't ever get those wrong, right? A is going to be 8, which means that the amplitude, the height of the function is 8. So 8 units above the x-axis and 8 units below. The B value, again, the period. Well, let's see what we got. The coefficient of x is 5, which is B. I do 2 pi over B. So this is going to be 2 pi over 5, and that is the period of this function. Now that's easy, and why is that so much easier than the last two we did? Well, let's take a look. It's a whole number. It's an integer. When B is an integer, I can just put it in the denominator and we're done. But when B is a fraction, I got to do this whole reversing nonsense craziness, right? So when it's a whole number in front, we're looking really good. C is going to be our phase shift. C divided by B. This one's going to stink. So I have a -5 pi over 6, which is C, and I'm dividing that by 5, which is B. Ugh, right? So we don't divide by fractions and all that kind of stuff. This is going to be -5 pi over 6 divided by 5 over 1, which is -5 pi over 6 times 1 over 5. Ugh. So this is going to give me, if we cancel the 5's out, this is -pi over 6. Yuck. So we have a -pi over 6 as our phase shift. Now, there's a clear negative there, which means we have to do the opposite, because again, we're still in parentheses here after I simplify that. This is right pi over 6 units. Okay, that's right pi over 6, because the negative would imply left, but we're actually going to the right. Okay, and then D, back to some normalcy. We got a down 2 again. Hey, real original, buddy. Huh? You could have at least made it a +2. Okay, so we're looking good. Let's finish up. Things to remember about this video. Number 1, transformations, or the rules of transformations, are constant over any family of functions that exist, right? So we have our vertical shift, vertical stretch, horizontal shift, horizontal stretch. Anything that we've done before in terms of the rules of characteristics in terms of transformations are applying to our trigonometric functions, right? So it doesn't matter, it's just the same rule, maybe a little bit different of a package with our ABCD methodology, but it's still the exact same thing. Number 2, know your ABCDs. Really important. I like to label them, right? We could put that up here too for things to remember. Label your ABCD process. It's going to make your life a lot easier. And then number 3, understanding each transformation will eventually make graphing simple. And again, think about what I said about amplitude, right? On that last one, the amplitude was 8 or 5 or both. It's that how many units above, and it's that units below the x-axis. So when we get to the graphing portion of this, you're going to know where this graph is going to go. We can also make a table of values, but the transformations is really your first step to understanding these functions way better. See you next time.